The most advanced chips in the world cannot be produced without a machine made by a single company. Before chips are designed, before they are manufactured, the systems that make them must exist. That system is controlled by ASML, a company that produces the only machines capable of enabling cutting-edge semiconductor production. Without these machines, companies like TSMC, Intel, and Samsung cannot operate at advanced nodes. This creates a structure where the entire semiconductor industry depends on one supplier at the very top of the stack. At the same time, these machines take years to build and cannot be easily replicated. Even if a competitor started today, it would take more than a decade to reach similar capability. This has turned ASML from a specialized manufacturer into a critical choke point in global technology. This is the tension, where control over a single technology places a company under pressure from forces beyond its own system. ASML's position was not created through market dominance alone, but through decades of highly specialized technological development. The company focused on lithography systems, which are used to print circuits onto semiconductor wafers with extreme precision. As chip designs became smaller and more complex, traditional methods of manufacturing reached their limits. ASML invested in extreme ultraviolet lithography, a technology that required entirely new approaches to optics, light generation, and system integration. This development process took decades and involved coordination across a global network of specialized suppliers. Many competitors attempted similar approaches, but were unable to match the technical requirements or sustain the investment needed. Over time, ASML became the only company capable of producing EUV machines at commercial scale. This created a situation where advanced semiconductor manufacturing depended on a single supplier. The monopoly was not established through pricing or acquisition, but through the inability of others to replicate the technology. At its core, ASML does not compete with chip designers or manufacturers, but operates above them as a supplier of critical infrastructure. Its machines are used by companies such as TSMC, Intel, and Samsung to produce advanced semiconductors. This places ASML at the top of the semiconductor stack, where its output determines what can be manufactured downstream. Each EUV system consists of thousands of components sourced from a network of highly specialized suppliers. Key elements such as mirrors and light sources require precision that only a small number of companies can provide. This creates a layered dependency where ASML itself relies on a tightly integrated ecosystem. At the same time, customers depend entirely on ASML for access to advanced lithography. This structure forms a system where multiple layers of dependency converge into a single point. The result is a position where ASML influences the entire industry without directly competing within it. As demand for advanced chips accelerated, the importance of ASML's systems increased across the entire industry. Artificial intelligence, data centers, and high-performance computing all require smaller and more efficient semiconductor nodes. These nodes can only be produced using EUV machines, which ASML is the sole supplier of at scale. This creates a direct link between industry growth and ASML's production capacity. As more companies invest in advanced chips, demand for EUV systems increases accordingly. However, the production of these machines is limited and requires long lead times. This creates a mismatch where demand grows faster than the ability to supply new systems. The more the industry expands, the more pressure is placed on this single point in the supply chain. This is where growth begins to amplify the importance of a bottleneck rather than distribute it. As reliance on ASML increased, a structural limitation became more apparent within the system. Each EUV machine is highly complex and takes months to assemble, calibrate, and deliver. Production cannot be rapidly scaled because it depends on precision components and tightly coordinated suppliers. This creates a capacity constraint where output increases gradually rather than in response to sudden demand. At the same time, customers require these systems to maintain their own production timelines. Delays in machine delivery can affect entire semiconductor manufacturing schedules. This introduces a dependency where timing becomes as critical as availability. The system therefore operates with limited flexibility, even as demand continues to grow. This is the hidden fragility, where a critical bottleneck cannot expand quickly enough to match the pace of the industry. As ASML's importance increased, its position began to intersect with geopolitical strategy. Governments recognized that control over advanced semiconductor technology could influence global power dynamics. Export restrictions were introduced to limit access to ASML's most advanced systems in certain regions. These decisions were not based on market conditions, but on national security considerations. This placed ASML in a position where it could not freely sell its products to all customers. At the same time, demand from restricted markets continued to exist, creating a gap between commercial opportunity and policy limitations. The company became subject to external decisions that directly affect its revenue and market access. This created a situation where business operations are influenced by geopolitical alignment rather than competitive dynamics. ASML's role shifted from a supplier to a strategic asset within a broader global framework. As geopolitical restrictions intensified, ASML's system began operating under constraints that were not present in its original model. The company faced limitations on where it could sell its most advanced machines, reducing access to certain markets. At the same time, demand from unrestricted regions continued to grow, maintaining pressure on production capacity. This created an imbalance where supply allocation became influenced by policy rather than purely by demand. ASML could not freely expand into all markets, even when commercial opportunities existed. This introduced a form of inefficiency where potential revenue could not be fully realized. The system became more rigid, with less flexibility to respond to global demand. At the same time, maintaining technological leadership required continuous investment and precision execution. The pressure is not from competition, but from operating within constraints imposed outside the company's control. ASML's position shows that controlling a critical technology can create both dominance and constraint at the same time. The company remains essential to the production of advanced semiconductors, supporting the growth of AI and global computing systems. At the same time, its role has expanded beyond manufacturing into a strategic position shaped by geopolitical considerations. In response, ASML continues to invest in research and maintain its complex supplier ecosystem. These actions help preserve its technological lead and ensure continued relevance within the industry. However, market access and operational flexibility are now influenced by factors outside traditional business control. Demand remains strong, but the company operates within a system that limits how that demand can be served. This creates a structure where growth is sustained but constrained by external forces. ASML is not under pressure because of competition, but because it occupies a position that cannot be easily replaced.